that you need shades. This is lesson 5.3, right? Mr. G Math coming at you live, 7202, with energy that you believe in yourself, right? And that you're building your perseverance. That if you believe and have perseverance, right? The world will watch out. So, let's read it together. Let's believe that we can do this. And we're going to listen and work as best we can. So, believe me that it's going to be a simpler lesson. Approximating with the tangent line. In many instances, finding the value of a function is difficult or maybe even impossible. With the use of calculus techniques, we can approximate what the value is by finding a y value on the tangent line to the function. Since this method involves using a linear function, that would be the tangent line, at a nearby point, it is sometimes called a local linearization approximation. So, I want you to see that the picture here is a circle, and on that circle we have a tangent line. What we're doing is we're taking a point very close to the circle and where it touches, but it's on the line but not on the circle, and it's giving me an answer that's close to what I want. So can you see where the line and the circle touch? So we're taking a point right beside it. Can you see how it's so close but not quite on the circle? That is what we're using to approximate. So it's easier to work with a line than often some of these ugly functions. So all we're doing is using the tangent line to approximate. Okay, look at number 1. It says that 2, -2 is a point on this graph. Use the equation of a tangent line passing through that point to approximate a y-coordinate. So to answer this approximation, we're first going to find the equation of a tangent line. That was 1,000 years ago. Here we go. There are 3 things I need. I need to know what the x-coordinate is, I need to know the y-coordinate, and I need to know the slope. So what's going to be easy? X-coordinate is, the y-coordinate is, and how do I find the slope of the tangent line? The derivative, because when I say slope, you say derivative, right? Slope, derivative, slope, derivative, slope, derivative. So what am I going to find the derivative of? Let's do it. What's the derivative? And I'm going to do this implicitly. Ready? Okay. The derivative of x squared is? The derivative of y squared, and y prime is my slope, right? Like when I get to that point, y prime is the derivative. That is the slope. That's what I'm looking for. We'll get there. Derivative of 2y is 2, and then y prime derivative of 4 is 0. How would you get y prime by itself? So what's the only term that doesn't have y prime?
2x.
So what am I going to do?
Subtract 2x.
And then when I factor out a y prime from what's left, right? What am I left with? 2y plus what? So divide that to the other side. We took the derivative, and the derivative of any constant is 0. So what's left? Can you see how I subtracted 2x? What's left over? If you factor out a 2y plus 2, divide it to the other side, this means the same as the what? How will I find the slope now? What will I do? Plug in what? X is what number? And y is what number? Solve it. So you know what x is, you know what y is, plug it in. Let's say negative 2 times 2 is, and 2 times negative 2 is negative 4, plus 2 is, so all together, and negative divided by negative, right, is positive 2. So, do we now have enough information to find the equation of a line? What would it be? What's the equation of a tangent line? What's the slope?
2.
X. Now, you could have went y minus 2, but we're going to do HK form. Or, sorry, y plus 2 on the left. HK form means that k, that y, stays the same sign. So you could have went y plus 2, the slope, and then x minus 2, right? Point slope form. HK says just get y by itself. So don't change the sign of the y coordinate, right? Just keep the y coordinate the same. Now this is the equation of a tangent line. What number am I going to plug in for x to approximate it? 2.1. And then I solve it. So 2.1 subtract 2 is 0.1. 2 times 0.1 is 0.2 take away 2 is negative 1.8. The big picture is you find the equation of the tangent line, the equation of a line, and then whatever you're trying to approximate, that's what you plug into. You plug into the line, right, to find what the y value is. So it says use the equation of a tangent line passing to that point to approximate the y coordinate at 2.1. So what is the y coordinate at 2.1? The approximate answer is negative 1.8. Then it says, what happens if it was 1.9? Do you see that, part B? So then I just plug in 1.9. Remember, the original tangent point is at 2 and negative 2. If you plug in an x value that's way far apart from 2, that approximation is going to be way off, right, as the line goes further away from the actual picture. What's 1.9 subtract 2? Negative 0.1. That's negative 0.2. So this would be negative 2.2. So the big picture, we're finding the equation of a line. You can do that, right? And we're using the equation of a line to then evaluate the function. That's it. Linearization, approximation. Here we go. Number 2. If f at 2 equals 3 and the derivative at 2 equals negative 2, use local linearization to approximate what the function equals at 2.01. Here, we're not even given what the function is, right? But we can still approximate with the tangent line. What 3 things do I need for a tangent line? So for number 2, what does x equal? 2, right? What does y equal? 3. What is the slope? What's the derivative at 2? So the slope is, what is the equation of a line using that? What is the equation of a line? I'm going to go y equals, the slope is x minus plus 3. If you want, you can simplify this. Negative 2 times x is negative, and negative 2 times negative 2 plus 3 is, and what do I want to approximate? At which one? 2.01. So what number do I put in for x? And then I solve it. No, 2.98. Right? Yeah. And so number 2 is an example. You'd even have a function to even plug in to find a y-coordinate. But we use the tangent line to approximate a close answer to it. That's the lesson.